Hello and welcome. In this video I'm going to show you how to create a code fix for the rosin analyzer we created in the previous videos. Let me show you what a code fix is. So here I have a count variable and I never used its value. So of course Visual Studio is showing me a warning here, but I can click on this light bulb and then click remove redundant assignment. So this here is a code fix. And if I click it, the line will be removed. So in this video, we will do a similar thing for our analyzer. So here, if somebody clicks on the light bulb, currently there's no code fix here. So here we will add a code fix called useImmutableArray.create, and if the user clicks on it, the code will be changed to something like this. Okay, let's get started. Okay. So in order to create a code fix, we must create a new class. Okay, I called this class creation CodeFix provider, and I must make it inherit from a class called CodeFix provider. Okay, so here I must implement the abstract members. Okay, so before implementing these members, I need to decorate this class with some attributes. Okay, so this export CodeFix provider attribute actually inherits from an attribute called export attribute. And this export attribute class is part of the Microsoft Extensibility Framework. So the Microsoft Extensibility Framework is some kind of dependency injection container. And Visual Studio uses this framework to allow extension developers to provide custom functionality for Visual Studio. The Microsoft Extensibility Framework is out of scope of this video, but what you need to know about this attribute is that through this attribute does Visual Studio find our CodeFix provider. So I have to give this attribute the name of the language, which is in our case C#, and a unique name for the provider, and I use the name of this class. Okay, this shared attribute is also part of the Microsoft Extensibility Framework, and it makes our class a singleton. That is, Visual Studio will create one instance of this class and use it throughout its lifetime. Okay. So let's implement these members here. So the fixable diagnostic IDs property is of type immutable array of string, and I can provide here an array of diagnostic IDs for which this CodeFix provider can provide code fixes. And here I can put whatever ID I want, even built-in IDs. That is, I can create code fixes for built-in analyzers. Like for example, the one I showed you in the beginning of the video about unused variables. In this CodeFix provider, we are going to provide a code fix for our analyzer. So here I'm providing the ID of the diagnostic we emit in our creation analyzer. Okay. So now we need to implement the register CodeFixes async method. So in this method, we get a parameter of type CodeFix context. Let me show you what we can access with this parameter. So here we have access to the diagnostics property. This gives us the diagnostics that we must provide code fixes for. And here in the documentation it says that all the diagnostics in this collection have the same span. In the case of our creation analyzer, we don't emit more than one diagnostic object for a single span, so it's safe to assume here that we will have only a single element in this collection. Another thing we have access to is the document property here, and this gives us access to the document of which analysis caused these diagnostics to be emitted. Okay. So I'm going to access the diagnostics property here and access the first element. and then I'm going to access the document property. Okay. Another thing we can do with this context parameter is to register a code fix. Here we tell the consumer, for example Visual Studio, that we want to provide a code fix. So here we need to provide an instance of the code action class, and I'm going to use the create method here, and the title I'm going to use for the code action is use immutable array.create. And when I call register code fix here, I must tell the consumer the diagnostic that will be fixed with this code fix. And here I need to return a new document object that contains the changes that I want to be made. So here I'm going to return the document itself, which means that I don't want to do any changes. So of course this is not the implementation that I want to end up with, but this defines the skeleton, right? So I'm getting the diagnostic, and then I'm creating a code action with a title use immutable array.create, and then here I should provide the changed document. In this video I'm going to start with the tests. I'm going to write a test first, and then I'm going to come here and do changes here to the document to make the test pass. Okay. So this is the test class for the creation analyzer. Let me rename it here. Okay. And it contains some methods here that I'm going to use in the test class for the CodeFix provider. Okay, I'm going to make them public, and then I'm going to create a shared class to hold these methods. Okay. Okay. And I will move this class to its own file. Okay. Then I'm going to create another test class for the CodeFix provider. Okay. 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 So I'm going to steal one test from the creation analyzer's tests. This one here. Okay. Okay, in this code here, we are using the full name of the immutable array type. And what I'm going to do, after I get the diagnostics, I'm going to give this diagnostic to the CodeFix provider and expect that it will change this code from this to something like this, right? So it's going to use the create method, right? Okay. We don't need to do these assertions here because that's the job of the creation analyzer tests. Instead, I'm going to call the CodeFix provider to provide a code fix for this diagnostic here. So what I'm going to do here, I'm going to call this register CodeFix async method, and it takes a CodeFix context. So the constructor here requires a document and a diagnostic, and we don't have here access to the document. So what I need to do, I need to do some changes to the getDiagnostics method to give me access to the document. Okay, but I'm going to do it in a way to make the original consumer of this method which is the creation analyzer test class happy. Okay, I'm going to copy this signature here. So this will be the overload that matches the original signature. And here I'm going to change the signature of this method to return not only the diagnostics but also the document. Okay. So this is the document ID. I'm going to extract it into its own variable. Okay. And here I'm going to return the diagnostics and the document object. Okay. Okay. So we can't have two methods with the same name and the same signature. To fix this, I will rename this method to getDiagnosticsAdvanced. Okay. 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 Let's use this method now. Okay, now I have access to the document. I can pass it here and the diagnostic. And here I need to pass a lambda that will be called by the CodeFix provider whenever it wants to register a code action. So one parameter of this lambda is the code action that was registered. And here we need to pass a cancellation token, but since this is a test, we can pass cancellation token.none. Okay. And here in the body of the lambda, we need to make sure that there is a code fix that was registered, but we need to make sure that there is only a single code fix that was registered, because we expect for this code that only a single code fix to be registered. Okay. Okay, so here I'm going to set this variable to the code action, right? And then here, after I call register CodeFix async, I need to make sure that this variable is not null, meaning that this lambda here was actually called, which means that the CodeFix provider actually did register a code action. Here, it also makes sense to check that the code action was only registered once. I can do that by making sure that this variable is null here. Okay. Okay. So if execution reaches here, we know for sure that there's a single code action that was registered, and this variable holds that action. So what I'm going to do now, I'm going to invoke this code action so that the code is updated based on this code action. So the API is designed in a way that we call a method called getOperationsAsync. And this method returns an array of what is called a code action operation. So what I can do here, I can loop through these operations, and each operation has an apply method. I give each code action operation a workspace, and the code action operation would update that workspace. So the effect of applying these changes is the code fix being applied. I'm not sure why the Roslyn team designed the API this way. There might be other advanced scenarios where having multiple operations for a single code action makes sense. Okay, So we need a workspace object here, and this should be the same workspace that contains the document that we gave to the CodeFix provider as input. So again, I'm going to update the getDiagnostics advanced method to also give me back the workspace object. Okay. So here I can return the workspace object, right? But this workspace object does not contain the latest version of the document, and let me explain why. Here, after we created the workspace object and obtained the solution, we updated the solution here, but we didn't apply the changes back to the workspace object. What I mean is, once we execute this line here, this solution variable will contain a different solution object than the solution object stored in the workspace, right? We also change the solution here again. Here also, we do changes to the project object, and again we don't apply them to the workspace. So what I'm going to do, after I make all these changes to the solution and project, I'm going to apply the changes back to the workspace, so that the workspace we return here contains the latest version of the solution. So you give the try_apply_changes method a new solution, and it updates the solution inside the workspace to match this one here. And this method could return false. For example, if the solution we provide here is not derived from the original solution of the workspace, then this method will return false. Also, if the workspace was updated while we were making our changes, then this method will also return false. So I don't expect this exception to be thrown in the test, but when you are developing extensions for Visual Studio, for example, different components might update the workspace, and this method might actually return false in that case. Another thing to note about the try_apply_changes method is that this method doesn't simply take this object here and store it as a reference inside the workspace object. And I'm saying this because here I'm using the project object to get the document object, and this will not return the exact document object that lives in the solution which lives in this workspace object. So what I'm going to do here, I'm going to use the workspace object, get the current solution, and get the document object. Okay. So as I said before, this workspace object would contain the workspace with the latest version of the solution. So here, once the changes are applied, we expect the workspace to contain the updated code here. So I'm going to get the updated document. So we expect the document object to be updated, but it's important to note here that document IDs do not change. So this is why I can here use the ID of the old document object to get the new document object. Next, I'm going to compare the actual updated code here with what I expect the updated code to be. Okay, and let me run the test. Okay, as expected, the test failed because we expected here the code to change, but because we still didn't implement the CodeFix provider, the code didn't change. And here's the actual value, which is the unchanged code. So now it's time to implement the CodeFix provider. And before I do that, let me rename this test here. Okay. So back to the register CodeFix async method. Here we obtain the diagnostic that we want to provide a CodeFix for. And what I can do now is access the node that generated the diagnostic. In order to do that, I'm going to obtain first the root node of the document. Okay. Okay. So here we expect the node that the diagnostic is referring to be of type invocation expression. And let me remind you why. So this is the kind of syntax that will generate the diagnostic, right? And this is an invocation expression, this being the arguments of the invocation, and this being the expression of the invocation. And what we would like to do is change the code to be something like this. Okay. So here we are expected to return a modified version of the document. So what I'm going to do next is create this syntax here and then create an updated version of the document that contains this syntax here instead of this syntax here. Okay. Okay, so here I'm using a class called syntax factory to create a member access expression that accesses the collections member in the system expression. And this simply creates the syntax for this piece of code here, right? Let me do the same for the immutable namespace. Okay, so here I'm accessing the immutable member of this expression here, and do the same for the immutable array type, and the same for the create method. Okay, so this expression here will contain this piece of code, right? Okay, now I'm going to create an updated version of the root node to replace this code with this code. Okay, so the syntax node class is immutable, and this means that this root object here is immutable. What I'm doing here is creating an updated version of the root node that is an exact copy of the root node, with the exception that this node is replaced with this node. Okay, and now I will return an updated version of the document with syntax root and updated root. Okay, let's go and try to run the test now. Okay, so the test passes. Okay, let's go back to the CodeFix provider and refactor the code. So here, instead of doing all this, I want to try to simplify the code. Let me show you how I would like this code to be. So instead of writing all this code to create the full member access expression, I want to create this helper method here to make this easier. Okay. Okay, so what I'm going to do, I'm going to take this string here, which in our case will be this one here, and split it into its parts, and then construct the member access expression. Let me show you how. Okay. So here I'm checking that there is at least two parts, right? Because you can't have a member access expression without at least two parts, right? And then I create the first member access expression, which is accessing the second part as a member of the first part, right? And then I will do a loop. So in the body of the loop here, I create a new member access expression having the existing member access expression as the accessed expression, and then the next part as the accessed member. So let me now run the test again to make sure that all is good. Okay, so the test passes. Okay, good. There is one more step related to deployment that we need to do before running the plugin. I'm going to the source.extension.vsix manifest file in the VSIX project, and then assets, and then I need to add an asset here of type MEF component, and then the source is a project in the current solution, which is the analyzer project. This is the project that contains the CodeFix provider. And as I told you in the beginning of the video, the CodeFix provider using the MEF framework to enable Visual Studio to discover it. Okay. Okay. Now let's run the plugin. So here we have the warning, and if we click on the light bulb, we have this option here, use immutable array.create. And if I click it, then the code is changed to use the create method. Okay. There is still more to do regarding the CodeFix provider. For example, currently we don't support the case where the full namespace is not used. For example, if I do this here, and then using system.collections.immutable, if I click on use immutable array.create, the CodeFix used the full namespace here, right? In this case, we expect it to do something like this, right? So this is something that we need to update the CodeFix provider to do. There are also other edge cases that we need to handle, and in the next video I will handle these cases. Thanks for watching.